Right, we are here and want to solve for x. Given the trigonometric equation cosine x plus cosine 2x plus cosine 3x equals 0, and we present a solution to this problem in a step-by-step fashion as follows. Right, so we have been given cosine x plus cosine 2x plus cosine 3x equals 0. And this is cosine x plus. Now, the cosine 2x is 2 cosine squared x minus 1 plus. Then we have here cosine 2x plus x equals 0. And this is cosine x plus cosine squared x minus 1 plus cosine 2x cosine x using the compound angle formula minus the sine of 2x, the sine of x, and the result is 0. Right, and we proceed now to write each of these trig functions as in terms of cosines of x, or we actually want to make sure that every angle that is double is broken down to a single angle. So we have cosine x here, and this one is 2 cosine squared x minus 1 plus cosine 2x is 2 cosine squared x minus 1 cosine x minus, now sine 2x is 2, the trigonometric sine of x, cosine x, sine x, and the result is 0. And looking at this with much caution, we proceed as follows. So we write here cosine x plus, okay, then we have 2 cosine squared x minus 1, 2 cosine squared x minus 1. Then we have upon expansion, if you expand this, you multiply through, it becomes 2 cosine cubed x. Right, so we have plus 2 cosine cubed x minus cosine x. Okay. Right, here we have the sine x times the sine of x, which is minus 2 sine squared x. Minus 2 sine squared x cosine x, and the result is 0. Right, upon further examination, we're able to see cancellation because cosine x minus cosine x gives us a 0. And we proceed then with the rest of the non-zero terms. 2 cosine squared x minus 1 plus 2 cosine cubed x minus 2. Sine squared is 1 minus cosine squared x. Cosine x equals 0 because the sine squared of x is 1 minus cosine squared of x. Okay, we distribute here, applying the distributive law, and we obtain here 2 cosine squared minus 1 plus 2 cosine cubed x minus 2 cosine x plus 2 cosine cubed x equals 0. Okay, we add these two guys here. 2 cosine cubed plus 2 cosine cubed. This gives us 4 cosine cubed x. Right, plus 2 cosine squared x minus 2 cosine x minus 1 equals 0. And this is what we have here. And now we proceed then to factorize this particular cubic equation. It is a cubic equation of the trigonometric type, and we need to obviously factorize this. So this is 4 cosine cubed x plus 2 cosine squared x minus 2 cosine x minus 1 equals 0. Cosine, 2 cosine. 2 cosine squared x is the common factor amongst the first two terms, so that we have 2 cosine x plus 1. Like this. And we factor out a negative here, so that we have 2 cosine x plus 1 equals 0. So 2 cosine x plus 1 is therefore a common factor, so that we have 2 cosine x plus 1 into 2 cosine squared x minus 1 equals 0. And now we have cosine x equals minus 1/2, or we have cosine squared x equals 1/2. Right, so we examine this very carefully, and we need to solve for x. We need to solve for x. Solving for x, we have the following. Cosine x equals minus 1/2. Or cosine x equals cosine squared x equals 1/2. Right, so we got cosine squared x. Right, cosine squared x equals 1/2. So that cosine is 1/2 and cosine x is plus or minus the square root. Cosine x is minus 1/2. Cosine x is 1 over the square root of 2. Or cosine x is minus 1 over the square root of 2. So we are here, and what we can clearly see is that we have 3 small equations. 3 small equations, namely, we have cosine x equals minus 1/2, or cosine x equals 1 over the square root of 2, or cosine x equals minus 1 over the square root of 2. So we're going to solve these part by part. So we're going to first solve cosine x equals minus 1/2. Solving cosine x equals minus 1/2. Okay, to solve these particular equations, we proceed as follows. So this equation, we proceed as follows. First, we find what we call the reference angle, which is arc cosine of the positive 1/2, which is 60 degrees. And so we realize something, that in view of the cast diagram, or the cast rule, the cosine is negative. In which quadrant is it negative? It is negative in 2 quadrants. What are they? What are those quadrants? They are basically the second quadrant and also the third quadrant as well. And so what we're then getting is, this is 180 degrees minus 60 degrees plus 360 degrees times k, where k is an element of z. 180 minus 60 is 120. Plus 360 degrees times k, k in z. Or we also have another case. Another case is the third quadrant. Another solution, another set of solutions is obtained in the third quadrant. In the third quadrant, we say 180 degrees plus the reference angle. So we're going to have x equals 180 degrees plus 60 degrees plus 360 degrees times k, where k is in z, which is 240 degrees plus 360 degrees times k, where k is in z. All right, so we have found some solutions there in the second quadrant, and also another solution in another set of solutions generated by using an angle 240, which is an angle in the third quadrant. We have also the other equation. We have cosine x equals 1 over the square root of 2. And we find first the reference angle here, which is arc cosine of 1 over the square root of 2, which is 45 degrees. Okay, 45 degrees. Okay, 45 degrees. The couple of things we note here, and the fact that we are using this cast diagram to solve for x, and we need to consider quadrants in which the cosine is positive in the first, where all are positive, but also in the third quadrant. Okay, now a couple of things therefore are at the epicenter of interest. But what we're then able to see is that x will be obtained as follows. For the angles in the first quadrant, it is clearly 45 degrees. And then we add 360 degrees. Why 360? Because the period of the cosine is 360 degrees. We have k in z. Okay, so another angle. Another angle is obviously 45 degrees there. Another angle would be the of the same size, but in the other direction. So you'd have as well minus 45 degrees plus 360 degrees times k, where k is an element of z. We also therefore can obtain the one in the fourth quadrant by using 360 degrees. Can use 360 degrees because it is close to 360 degrees. So 360 degrees minus 45. 360 degrees minus 45 is going to take us to that. Plus 360 degrees times k in z, which is 315 degrees plus 360 degrees k in z. So yeah, 45 degrees and 315 degrees. Or, so in other words, you identify the solution here at 45 for the angle in the first quadrant, or minus 45 in the fourth quadrant, or 315, which is exactly an angle in the fourth quadrant. Right, but we also have another equation to solve. We also have cosine x, which is minus 1 over the square root of 2. And we get here the reference angle, which is arc cosine of 1 over the square root of 2, taking the positive ratio, and that gives us exactly 45 degrees. Looking at the cast rule, cast diagram. Okay, the cosine is negative in a couple of quadrants. It is negative in the second, but it's also negative in the third. Okay, so in the second quadrant, we're going to say x is 180 degrees minus 45 degrees plus 360 degrees by k, where k is in z. So you have 135, 360 degrees by k, where k is in z. Right, so, but we also have another angle now that appears in which quadrant? Another angle that appears in the in the third quadrant, because the 135 is an angle in the second quadrant, but another one appears in the third quadrant, which is exactly 180 degrees plus 45. So we have also x equals 180 degrees plus 45 degrees plus 360 degrees by k and z. So which means therefore x is 225 degrees plus 360 degrees by k, where k is in z. So we have found a solution now. 225 in the third quadrant. And we've also found a solution now, which is 135 in the second quadrant. And obviously we add multiples of the period. Okay, and now this is the end of the set of solutions. Just a recap, we do remember that when we actually factorized the trigonometric equation, which was a cubic equation, or an equation of third order. Right, so we were able to get three little small equations, baby equations. The cosine x equals minus 1/2, cosine x equals 1 over the square root of 2, or cosine x equals minus 1 over the square root of 2. And then now we have cosine x, we got cosine x equals minus 1/2, and that has led to 120 degrees here, and there's another one which is 240 degrees, and both the 120 is in the third, and 240 is in the fourth. Obviously, therefore, we're able to solve this equation here. Right, so we're able to solve this equation here in a step-by-step fashion, and we got the 120. But also the 120, obviously, we can identify it as an angle in the second quadrant, but also there's another angle in the third, which is the 240. Went on to solve the second one, cosine x equals 1 over the square root of 2, and obviously we obtained an angle in the first quadrant, which is exactly 45 degrees. And we added multiples of the period of the cosine 360 degrees, and also we went on to deal with the other angle here as well, minus 45 degrees. And also the minus 45 degrees is an angle in the fourth quadrant, and we also did 360 minus 45, which gave us 315 degrees. Cosine x equals minus 1 over the square root of 2, and we're able to get 135 degrees there. As an angle in the second quadrant, but also we found another angle there in the third quadrant. So yeah, we're done with this particular question. It was a very interesting one. Thanks everybody for your time and attention and for watching, and goodbye to you.